This particular problem is taken from Pearson Publishing, My Stat Lab, in reference to Elementary Statistics by Larson Farber. The heights of fully grown trees of a specific species are normally distributed with a mean of 50.5 feet and a standard deviation of 6.25 feet. Random samples of size 19 are drawn from the population. Use the central limit theorem to find the mean and standard error of the sampling distribution. Then sketch a graph of the sampling distribution. The first part of the question, the mean of the sampling distribution is mu sub x bar equals. And in this particular case, using the central limit theorem, the mean of the population will be equal to the mean of the samples. So this will be 50.5. The standard error of the sampling distribution will be sigma sub x bar. And in this particular case, the easiest way to calculate this standard error would be to use StatCrunch. So left-click StatCrunch over here. We'll open StatCrunch, and then we'll go to Stat, left-click that. We're going to scroll down to T statistics since our sample size is 19. Highlight one sample, and then highlight with summary and left-click. Type in the sample mean, which is 50.5. We're going to type in the sample standard deviation of 6.25. Our sample size is going to be 19, and then we're just going to simply calculate a confidence interval for mu at a level of 0.95. Left-click compute, and then we'll get this screen right here, which tells us what our standard error is, and that's what we're looking for. My stat lab wants us to round to the nearest hundredth or 2 decimal places, which in this case will be 1.43. So we'll go ahead and type 1.43 in, come down here and left click check answer, and we did a good job. Now our next part of the problem is choose the correct graph of the sampling distribution below. Since the mean is 50.5, we'll look at all three of these particular graphs and we can discount C, because this is not going to have the mean on there. So we're going to look at graph A and graph B. But for this graph, we are going to use the fact that our standard error, our standard deviation for the samples, is 1.43. So we'll add 1.43 to 50.5, and that way we can get 51.93. We'll also subtract 1.43 from that, and we'll get 49.1. And we'll see that one standard deviation from the mean on this first graph is 49.1 to the left of the mean and 51.9 to the right of the mean. If we come over here and look at this second one, we'll see that they actually use the standard deviation from the population, which was 6.25. That's not what we want. We want the graph for the sampling distribution, which is going to be graph A. We'll left click final check, and we're done with that.